All right. So you can see my screen here with Docker Hub. I'm sharing the
Yep.
right one. Yep, great. So this support workshop was around Docker and kind of what it means to developers, how it maps into Octopus, and how I guess some of the support questions that might come up, or even how Docker could be useful for support in quickly spinning up and reproducing test cases and things like that. So we should start with why Docker even exists. Like, what problem does it actually solve? And Docker is, I think it's safe to say that it started out as a very developer-focused platform. It was something about giving developers or making them more productive. And so it does that by basically providing a way of packaging and distributing and running completely self-contained applications. And so what we mean by self-contained is that it includes all the tools that you need to build and run, and it includes all their dependencies, and it will set fixed versions. So you can imagine for a sample application, like this is our random quotes application. This is just a ASP.NET Core app. And I mean, .NET does a pretty good job these days of giving you repeatable builds with the CLI. So you'd go in and you would restore any dependencies, and then you would publish a compiled output. But actually, even just to get this .NET executable is not quite as easy as it seems. You'd have to go off and install, grab the download for the specific version that you need. And on Linux systems, there are other dependencies that sometimes aren't obvious. So even just getting to the point of being able to run this command line tool can be a fair bit of work. So what Docker does basically is gives you the ability to create a self-contained image, and that image is going to contain everything you need. So this is an example of a Docker file, and this is how Docker images are built up. Most Docker files written by end users are based on images provided by someone else. And this is one of the benefits of Docker. Actually, everyone's gotten on board, and every tool maker has officially supported and regularly updated images you can base things on. So that's a really nice library to lean on. And it will go through and then run all the steps for you. And so the end result of this execution of this Docker file will be an image that anyone can run just with a few Docker commands. They don't need .NET Core. They don't need any special dependencies at this point. Everything has been provided for them. So that's why developers love Docker, or that's why I guess maybe there's a love-hate relationship, but they've definitely gravitated towards Docker. Just because it is convenient, it is well supported, there is a huge library here, and it does solve a lot of these problems of, my machine has slightly different dependencies to your machine, and so things will work slightly differently. The other nice thing about Docker is that it allows you to run things side by side. So you can imagine, what would it take to run, say, MS SQL 2017 and 2019 side by side on a single Windows computer. I'm sure it can be done, but it's I suspect you're on your own as to trying to find out where all the information is that you need to have them run side by side. And likewise, how do you run something like Jenkins or TeamCity side by side with two slightly different versions? These I'm sure they're all possible to do, but they all have their own ways of managing those side-by-side issues. Whereas Docker, again, is just, because everything's self-contained, you can just spin up two images side-by-side, and they're isolated from each other. And you get that nice ability to test without the headache of constantly uninstalling and reinstalling. And so that's another benefit that I think definitely support teams could lean on in diagnosing issues. So one image that I will call out that we'll reference later on here is the the workers tool image. So this was the new feature that we added recently in Octopus, where you could run your deployments inside a Docker container. I'm sure most of you have seen this, but I'll just call it out anyway. So this it's this feature here, execution containers for workers. And that is the ability here, it's these steps, to execute individual steps inside a container. And so maybe have to run, there we go. It only shows up when you run on server or worker. And this is where you would specify that, that image. And so we did this because as Octopus was growing, the combination and different versions and different operating systems that we had to support, and with all the tooling and the different clouds and things like Terraform and whatnot, it was just becoming unmanageable to ship these tools with Octopus. And so we ended up in this half-half position where we shipped some tools. We expected the customers to have their own local installs for others. And what we were shipping was becoming out of date very quickly. And we couldn't satisfy everyone. Like, some people needed the old versions, some people needed the new versions. And so this is a very good use case for using Docker, because we get the ability to bundle up a whole bunch of these tools into a self-contained image, and then we can publish them, and we can publish different versions of them, so people can pick and choose and remain stuck on whatever particular version works for them. We'll dive into this a little bit more later on, but I just wanted to call out that this image here comes from this Docker Hub repository here, and that's the Docker file that generates those images is open. This is an open Git repo, and you can view the individual steps that go into making up this image, and this will tell you what tools and what versions are exposed. So this is a good one for support as well. You may need to go back and confirm which particular version of an application exists on these worker tool images. The team that made this image has made it easy for you by extracting out the versions as arguments here. So you just look at the top here and you get those lists. So to run Docker yourself, you'll need to have like the Docker tool installed, and that's just free. You just download that from docker.com. It's available for Windows, Linux, and Mac. Something to be aware of, though, is that Docker images are either Linux images or Windows images. So there's no such thing as a Mac Docker image. The Macs just run like a virtual machine that exposes Linux. So when you're running Docker on a Mac, you're actually just running the Linux versions of the images. On Windows, you get the option to switch between Windows and Linux. Windows containers are not quite as popular. It took Microsoft a few years after Docker was released for Linux to add the capability of having things called Windows containers. So they're not quite as popular, but we do actually ship some Windows containers ourselves. Octopus and the Tentacle are shipped as both Windows and Linux containers. But that's just something to be aware of, that there is this distinction between Linux and Windows containers. Most of what I'll be doing here today, in fact, all of it will be Linux container based. That's where most of the sample applications and base images that we want to use come from. But again, it's just useful to be aware that such a thing exists as Windows containers. So what I wanted to do is just look at some of the concepts that make up Docker, the Docker ecosystem. Excuse me. So we've already seen Docker images. So the Docker image is just this package format that includes all the files that represents your self-contained application. Those images are built um, from this Docker file. And so this command docker build will run through the steps that were listed in this file, and the end result is an image. So that image currently, because I've built it locally, only exists locally. What you could do then is push that image to a registry. And so a registry is a service usually provided by a cloud provider or Docker itself. So in this case, Docker Hub is the kind of the default open source registry for most of the base images, but things like Azure and AWS and Google all provide their own Docker registries as well that you can use to host private images. And so I could push this image up to a registry like Docker Hub and share it with the world. Images are then used to create containers. You can think of a container as being like an instantiation of an image. And so what I'll do here is actually take the Fedora image that's provided by Red Hat, and that's also been put up on Docker Hub. And I'm going to run the image in an interactive mode. That's what this IT means. I'll be running the bash command, so that just gives me a terminal that I can start typing in, and I'll give this image the name of Fedora as well. Oh, I've already run Fedora. Let's call it something else too. And so what's happened here is that I've previously downloaded this image, but if I hadn't, Docker would have reached out to Docker Hub and pulled it down. And now I've created a container called Fedora 2 based on the image called Fedora. And so as you can see, when I'm inside, it's kind of like I've SSH'd into a virtual machine. I get a root file system that's, I mean, I'm running on Windows, so this is clearly not my Windows file system. This is the file system of the Docker image. And yeah, so this image is then kind of self-contained and isolated from other images that might run side by side. So I could run this again, and I'd have a completely separated instance here. So if I Fedora 3. I've just created a file called Fedora 3 in this instance. And if you look here, there's no such file here. So the two are isolated from each other and don't typically talk to one another unless you've made efforts to expose some shared resources between the two. One thing I should probably call out though is that Docker security isn't quite at the point yet where you could trust these two images, these two containers to not interfere with each other. So we're not quite at the point where you could run untrusted code in containers and be guaranteed that they're not going to either hack each other or get back onto the main system. For that sort of thing, virtual machines are still better. But certainly if you're writing the code that you're running and you trust it, then virtual machines offer a lot of benefits over, Docker images offer a lot of benefits over virtual machines. So the other thing, so what I've done here is I've built an image. What I should actually have done is given that a name. So a name is quite often something like this. So that M. Casperson is my username on Docker Hub. And then let's just call this test. Oh, I should have put a -t. And so what that will do is now give that image like a user-friendly name. And you'll notice even though I didn't type it in, it's added this :latest. Latest is a shorthand in Docker to say that this is just the latest available image. And so quite often, when you're pulling down images, you won't specify a specific version, and it will default to latest, and everyone just kind of assumes that that means the latest available image. You can actually specify versions though. So here we go. I've added the colon and a version number, and I would now to pull this down from Docker Hub. This is no longer necessarily the latest one. I would have to know that version there. And these concepts of repositories. Actually, I should say. So this is a registry. Docker Hub is a registry. A repository is like an individual, like a place where individual images are uploaded, and those images can have multiple versions. So registry holds repositories, repositories hold images. And we'll have to map all these naming conventions back into Octopus because we use slightly different terms. But I'll jump in and have a look at that and how they all map up later. And so images, so this is your repository, and this tag is a version. So we've seen one command here, so docker run. So this is typically how you would launch a container for the first time. And spell. And so here we've just used the ls command, and you can see that Fedora 3, which was this one, is still running in the background. Fedora 2 actually just exited because I exited the only command that was running. So when that exited, the container kind of just shuts down. So the common other concepts in Docker are volumes and ports. And so what you'll notice in Docker is that the file systems are ephemeral. So this file here that I've created, what I'm going to do is actually remove that container. So I started it, I effectively stopped it by exiting out of the shell, and now I'm going to remove the container. Oh, it should have been Fedora 3. If I run this again, you'll notice that file that I created doesn't exist anymore, this Fedora 3. And so what happens is you can start, stop, and restart containers, but once you remove them, any changes are gone. Like that file system doesn't exist anymore, and you've lost all your work. So what I should be able to do actually is, so I've just stopped that. I'm going to restart it, and that will be, Fedora 3. Oh, I should touch a file because I deleted it. Okay, so I stopped and started again, and that file exists. So I can do like a turn it off and on again, and I retain my files. What I can't do though is kind of update that image anymore. So you can imagine a situation where you've downloaded a Docker image that hosts, say, MySQL for, MS SQL, for example. And all the database information is stored within that container. And you want to update the version of MS SQL. I mean, what do you do at that point? You're kind of stuck because you can't put the latest MS SQL image into an existing container, and so you'd have to go through and like back up and restore and do a whole song and dance about it. So what you'll find is that the solution here is to use volumes, and what volumes do are either map files from your local system into a Docker image, Docker container, or it will mount what's called a Docker volume. And a Docker volume is just like a specialized Docker managed thing that persists files outside of the lifecycle of a container. And so in that case, you could remove a container, but the associated volumes wouldn't be removed, and they would be available to be mounted back into the next container that you wanted to run. So we'll see that in action with some of these examples. Just going to try and pull up an example we can use. I'll try and get that later. So ports are the other thing. Ports are basically the primary way that that Docker images talk to each other. And so this here is the sample command that Jenkins gives you to run its Docker image. I've just grabbed that from their documentation here. So they provide a bunch of example commands. And we'll actually see this volume thing play out here. So this is going to create a volume called Jenkins Home. And that is the place where all the persistent Jenkins information is going to be stored. And that's what we can reuse between containers as we upgrade the base image. We also have these two port mappings. So these are going to take the local system port of 8080 and then route that into the container on port 8080. And it does the same thing on 5000. And it's important to note that actually these don't have to match. So in this case, I've taken the local port of 9999 and passed that in as to port 8080. And so we can see that if we open this up, we should eventually get the Jenkins welcome screen. Can just take a second or two to boot. There we go. And so this is what I was talking about, as you can run things side by side. If I wanted to run two versions of Jenkins side by side, all I need to do is potentially change these system ports here so they don't conflict locally. And then I'd probably use different volumes as well. But then I'd be free to run different versions of Jenkins side by side. So their examples here have told me to use the LTS version. They also have a latest version, so it's going to be their bleeding edge, and I could run those side by side if I actually wanted to. In fact, we could probably even do that. What I'll do, I'll just get rid of this volume mounting. So this would make any data that I generate in this container ephemeral. I'm running a very big risk here of losing any of my changes. But as long as you can see here, it's defaulted to latest. It's going to download that. That might take a little bit. But what's going to happen is I could open this port here, and I've now got two versions of Jenkins running side by side. So the takeaway from this is that persistent data needs some special attention in Docker. You will need to either specify these Docker volumes or mount file systems on the local machine into a Docker container to make sure you don't run the risk of that just disappearing once you remove the container or try and do an upgrade. One quick thing I do want to point out here is that the Docker tool has a nice UI. So if you right click on that icon and go to dashboard, it's going to give you a list of the running containers. These funny names here are just, you kind of just get a random name if you don't specify one yourself. So Fedora 2 and 3 are the ones that we specified. I never specified a name for the Jenkins, so you just kind of get these mixed up names that give you something unique to reference, but of themselves don't really mean anything. But this is a handy UI as well if you don't necessarily want to remember all the Docker container run, stop, whatever commands. You just get these nice little buttons here of stop, restart, and delete. That's up and running. Let's jump in. Yeah, there we go. So we got two different versions of Jenkins running side by side. And so that's kind of nice. That's a great debugging technique, actually, especially for support people who quite often have to reproduce issues in specific versions. You can imagine how time-consuming it would have been to download and set up a specific version of Jenkins, and then download and uninstall that, and then download another specific version. It gets a bit tedious. Docker makes it a lot easier. So how do all these concepts then map into Octopus? So what we've seen is that Docker Hub and the other services provided by clouds like Azure and AWS and Google, these are registries. I keep getting them mixed up. These are registries, and they map into Octopus as feeds. Just be aware that the feed URL doesn't necessarily match the one you put into a browser. That's just something you'd have to get from the documentation of the particular provider. But in this case, this is the URL for the Docker Hub registry, and this comes up by default if you create a new feed. Nope, not GitHub repository. Docker. Right, there you go. So that one just came up for me by default. So registry equals feed. Repository equals package ID. So if we go, let's go deploy. That may not be right. Let's just grab this one. Right, so this is a repository. Just have to keep double checking that. Repository is this, but that's going to be reflected in Octopus as a package ID. And the versions, sorry, the tags, I should say, then show up as versions. So if we go, let's create a new. So what I'll do here is just add a Docker container as an additional package in a script step. Yeah. It's a little bit slow this morning. There we go. I'll just make that run on the server. So what we'll see here is these versions, the tags are showing up as versions here. So these will match these here. So that's how the Docker terminology maps into Octopus. It's a one-to-one mapping. There's not a lot of ambiguity there. There's just, I think people might get tripped up on some of the different terminology that the two tools have used. So speaking of worker tools, it's a good opportunity to see how they actually work in practice. So what I have here is a deployment that was done using a worker tool. And what we'll see in the logs here is the first half of the command that was used by Octopus to execute this, our special container. And hopefully you'll start to see some of those other concepts falling into place here, into how Docker is actually used in the real world. So what we say is Docker run. RM just means clean up this image once you're done. It's like, it just saves you from having to do Docker container RM, for example. We set some environment variables. This one here sets the working directory, I believe. So that will be just the directory that you land in, I think, if once you launch this container. So V, these are the volume mounts. We saw before that we, with Jenkins, we were mounting this one here is a Docker volume, and that will be created by Docker for us. But the other option is to actually mount a file system from the local machine into the container, and that's what we've done here. So this has mapped the I guess the tentacle working directory on the server that the tentacle is running on into the same directory into the container image. And we've done the same here with the Octopus server directory. This is where Calamari and the other executables will exist. So we've mounted these two directories, and then we've called, we've specified that we want to run our worker tools image. So what you don't actually see on the end here is the command being called. If you recall, the command we were running was something like bin bash. What does actually get executed but doesn't show here is the Calamari command. And that Calamari command is most likely going to be executing files from this directory, which is then mapped outside to the host server, in this case, in a directory of the same name. And so what this gives us the ability to do is all these applications, all these specific versions, and all their dependencies are now available to Octopus. So I can, I can run Node, and I can run Helm, and I can run the Octopus CLI by virtue of the fact that I'm running inside this container. And that's really useful for us because it decouples the versions that we would normally have to package into Octopus itself and release on Octopus's release cadence. That's all decoupled now. We can release these images whenever we need. New releases get new versions. If an old version is working for you at the moment, that old version will remain. So we're not breaking anyone who's got a system that's up and running. And so I expect this to be more popular as it starts to take off. Just to wrap it up, then I would like to try and point out some of the ways that Docker can maybe make support easier. And I think I've already shown one here, like Jenkins. If you get a support ticket in, how do I've noticed this issue in our plugin in Jenkins, or a plugin is doing something strange on this particular version. To replicate that yourself without Docker, you're basically forced to download Jenkins and install it. And then if you have to test with a specific version, obviously you have to uninstall whatever version you had and install another version. It's a lot of mucking around. But yeah, all that can be replaced with that, right? With one command and a little bit of download, you've got a complete Jenkins installation ready to go. And getting that up and running and reproducing issues should be fairly simple at that point. So it's not just Jenkins. Other build servers like TeamCity, they have Docker images. Bamboo has one as well. So I think there's a good opportunity to use Docker as a way of quickly reproducing issues for customers without the hassle of downloading and installing all this software on your local machine and trying to maintain it and juggle versions. Another thing you can do is use the Docker images as kind of just a temporary playground for our Linux tooling. So for example, let's say someone comes in and says, I'm running Fedora, I'm trying to install the Tentacle, and yeah, stuff's just not working as I would expect. To do that without Docker, again, you're probably setting up a virtual machine somewhere or spinning up an EC2. It's a fair bit of work, I guess, to even get to a point where you can start think about reproducing errors. But what you can do with Docker is just spin up a Fedora image, and you get access to most of the tooling that you need. The images are very bare bones, so what I'm installing here is a lot of support tooling that the Tentacle needs. Actually, this Tentacle thing probably won't work. But as you can see, for all intents and purposes, I've really just SSH'd into a Fedora virtual machine. The only difference is it took, all of 2 minutes to get it spun up. And yeah, then I'm free to go in and install my Tentacle and play around and try and reproduce an issue. And then it's very easy to just dispose of it all at the end. Go into my dashboard here and hit the delete button, and I'm done. And it's all cleaned up because it's all self-contained. There's no residual files left over, nothing to worry about. It's very quick and easy to sort out. So as you may expect, there's a lot of support among Linux distributions for Docker. You get Debian has one. We've seen Fedora, Ubuntu has one. To be honest, I think almost every Linux distribution would have a Docker image somewhere. So no matter what the operating system any customer is using and may raise a support issue for, there's a good chance you can just support it with Docker. I will actually just run through this installation of the Tentacle though, just to prove that it works. So these, right. So these dependencies, wget is just a downloading tool. Hostname, find utils, and ICU are either required to support Calamari or the Tentacle itself. So I'm just following the instructions from the documentation that we have online for installing a Linux Tentacle. Okay, yep, it's all fine. All right, so at this point I've actually installed the Tentacle, so I've just reproduced any installation questions someone may have had. So if we just go through and do the actual install. Actually, that's fine. That's fine. Let's go to just dump this on my cloud instance. B2. Just bear with me while I grab that password. Target. this one. That's fine. And environments will be roles. All right, let's see how we go. So one thing you will find though is that these obviously aren't full Linux environments. Systemd is like a service manager for Linux that typically doesn't exist in Docker images. But all we need to do here is just run it interactively. Okay, there we go. So if I jump into my instance now, Fedora, that's my tentacle. So hopefully you can see that it's far quicker to be reproducing issues for Linux tooling in a Docker container than it would be to try and spin up a virtual machine or an EC2 instance. It takes minutes here, whereas it might take you an hour or something to do it in a full VM. And so I think that's going to be quite useful as well for support people, especially given the huge range of base Docker images that the Linux distributions provide. The last thing I want to point out is that Docker also provides a way of distributing kind of command line tools. So the more typical use case for Docker is you package something like a web app. It's something that runs for a long time, opens up a network port and receives traffic. But it can also run once-off commands. And in this case, we've packed up the Octopus CLI as a Docker image. This, I don't think this gets a huge amount of use today. But I suspect this is going to start to become more popular with platforms like GitHub Actions, because GitHub Actions will let you run Docker containers as steps in a build process. So you can imagine the last step of your build process might be to use, here we go, we just printed the help, would be to use the Octopus CLI container to maybe push an image or create a release, something like that. So that's another use case for Docker, and something that I think we'll start seeing more interest in as time goes on. That was it. I've run through everything that I wanted to show off there. So is there any questions or anything that I could clear up? Or any other support issues that you may have come across that we can maybe talk about and see if we can get to the bottom of?
Nothing recently comes to mind, but yeah, that was great. Definitely see huge potential time saver with that.
Yeah, I think it'll just for reproducing issues. I think it just makes it easy to get to a point where you can either send an issue off to QRF or continue on in support and make that decision hopefully quicker than it might otherwise have been. All right, well, thanks for listening. I'll grab the link to the recording when it's ready, and yeah, I'll see you next time.
Cool. Thank you very much.
Thank you. See ya.